Hello everyone, hopefully you're doing well. In this video, we're going to continue with chapter 2, equations, inequalities, and problem solvings. So far in this chapter, we went over linear equations in one variable, an introduction to problem solving. We go also over formulas and problem solving, and we took a look on linear inequalities and problem solving. In this video, we're going to focus on section 2.5, compound inequalities. Our objectives is really to find the intersection of two sets, also solve compound inequalities containing and finding the unions of two sets and solve compound inequalities containing or. So compound in mathematics means most of all like joining two sets together, two or more sets together. So the intersection of sets, the solutions set of a compound inequality from with and is the intersection with the solution sets of the two inequalities. We need to focus this on and. We either said and or we said intersect. Intersect, remember, for two, intersection, like you see, if you have A intersect B, it's really mean that is X such that X is an element of A and X is also an element of B. All right. So meaning, if I tell you that I would take a trip to the Caribbean, I would visit Jamaica and Haiti. So if I come back, I visit only Jamaica, that means I didn't keep my promise because I said and Haiti. So I must tell you that I visit Jamaica and also I visit Haiti because it's an intersection. So the compound inequalities from within is the intersection of two set of two inequalities. That means it's the common area. So and so if you have two, remember it's we call for intersections, of sets. Let's say if you have A has the element 1, 3, 5, 6, 7, 9, and set B has the elements of 2, 4, 6, uh, and eight, for example, what is the intersection of A and B? That means what elements you see in A, you also see it in B. The elements you see in A, or you also see it in B is, I mean, all the elements you see in A and you see them in B. What are those elements? Yes, it's only six. You see six in both sets. Six is here and six is also here. So this is the intersection of sets. So the intersection of two sets A and B is the set of all elements common to both sets. A intersect B is denoted by A with that symbols you see right there. Let's see another examples based on this. So if I have a set, find the intersection of these two sets. What is the intersection? I can give those sets a name if I want to. I can call this one A and I can call this set B. So if I rewrite it as A intersect B, what elements you see common to both sets? The elements you see the elements you see in A, you also see them in B. I see 2 is not in both. So I see 4, both sets. 6, both sets. 8 not, 5 not. So the intersection is 4 and 6. Okay, so the number 4 and 6 are in both sets, so the intersection is 4 and is a set 4 and 6. Okay, all right. So if you're okay with these examples, we're going to solve compound inequalities now containing the coordinations and. So solve and graph the solution for x plus 4 greater than 0 and for x greater than 0. For this one, the first thing to do is to solve each of them. If you solve x plus 4 greater than 0. Remember, if you subtract 4 from both sides, subtract 4 from both sides. So solutions is x greater than negative 4. So at this point, this is the set builder notation solutions. Like when we know x is greater than 4. So you can either say that x such that x is greater than negative 4. But if you want to graph this one on a number line, look at the number line. So the number line, let's use that line. If we have 0 here, 1 here, 2, 3, etc. On the left, we're going to have -1, -2, -3. I know I put it too far. -4, -5, etc. So I put those arrows to say we continue indefinitely. Now, what you can see here is like, because x is greater than -4, that means I'm gonna go to the right because it's greater than. So my line would go this way. So that would be the solution. So if you want to write the solutions in different ways, we know the answer would be -4 infinity. So that's the answer for the first one. Now, if you look at the second exercise, okay, look at the second exercise, what's going to happen if we go with a green. So you have, remember, and, okay, for x greater than 0, how to obtain x in this situation? Yes, in this situation, what we can do is divide both sides by 4. So x would be greater than 0 divided by 4 is what again? Yes, it's 0. All right. So you know the set builder notation would be x such that x is greater than 0. Now, if I graph x greater than 0, I put -4 again, so that would be 0. All right. So what I can do is really grab the same line. And then if I have 0, -1, -2, -3, -4, -5, I can continue indefinitely. Then I have 1, 2, 3, and I can continue indefinitely. Now I can do the same here where I would start because remember x is greater than 0. This is 0 here, and because it's strictly greater than, I can go to the right. And I use parentheses, or I can use a dot, an open dot. Okay, so this is the graphical notation or graphical solutions for these two inequalities. Now, we are ready to answer the question asked. The question asked is to solve and graph the solution for the compound inequalities. The compound inequalities, remember, we have and. And means compound inequalities. That means what section do you see belong to both sets? So what we're gonna do here is to go over x is greater than -4 and x greater than 0. So all we need to do is to graph a line where we put, I'm gonna put 0, -1, -2, -3, -4, -5. I know the scale is not properly distributed. I apologize for this part. Okay, so what we're gonna do in this case, now we need to take the intersection. What is the intersection of these two of these two. So what section between the first one, and the second one you see in common? So that's what we're gonna do. You're going to see here, if I put in a straight line on 0, you see on the right of 0, I mean, this section is common, but on the left of 0, only x greater than -4 has a shaded area. So meaning the common area for this one will start at, will start at 0 to infinity. So this is the common area right there. So that's the compound inequalities involving and containing and. So that's the compound inequalities. For this one now, solutions in interval notations would be how you can see this one, interval notation. We put the graphical, but we're gonna say interval notation for the solution set would be 0 to infinity, and that will be the answer for this compound inequalities. We can continue with many examples, like the second one right there. We can do many examples if possible. These examples also help us to see, to solve with compounds. Only compounds can be presented, containing and can be presented in this format. But if you see, not with containing or, but for and, yes. First of all, remember, either you solve an inequality, or you solve an equation, you solve for a variable. You must obtain something at the end. You're not just solving for a number, you're solving for a letter. In these inequalities, I see the letter x. That means I need to isolate x to make sure that x is on one spot by itself. But the problem, I have a combinations of numbers and letters in the middle. So the first thing to do, I need to remember the distributive property where I can distribute 4 to these two in the middle. So what is gonna give me 4 times 5 is 20. 4 times negative x is negative 4x. And that would be between 0 and 8. Now, after I do that, I need to isolate x. I need to make sure that x is all by itself. Okay, so make sure we solve it for x. So what we're gonna do here is subtract 20 everywhere. We're gonna subtract 20 everywhere because we must have only x in the middle. So we end up having cancel the 20 in the middle. We have only negative 4x left, and we have negative 20 on the left, and we have negative 12 on the right. Now, we must have only x, not negative 4x. So what I'm gonna do is divide everywhere by negative 4, everywhere by negative 4, everywhere by negative 4. So I end up having only x. That will be between negative 20 over negative 4 give you positive 5. But the problem, the symbols would change, because the symbols would no longer be the same, because we change the negative into positive in front of the x term. So what happened? That one right there would be less than or equal to 5. And this one would change also to greater than negative 12 over negative 4 give you 3. Okay? So if you want, you can either leave it like this, or you can just rewrite it as x. X would be between greater than 3, but less than or equal to 5. We write the exact same thing, but except we just write it a different way. Now, this is the solutions. If we are asked to graph it, if we are asked to graph it, we can make a straight line and identify 0, and then we go 1, 2, 3, 4, 5, 6, 7, etc. And remember, on the left of 0, you have all the negative. I just leave it like this. I know you can continue on your own. Now remember, x is only between 3 and 5. But the problem, 3 is a parenthesis because it's strictly greater than or less than, x is greater than 3. All right. And then we have and x is less than or equal to 5. Less than or equal to, remember, if you have less than or equal to or greater than or equal to, we use bracket. So this is the solution set. The solution set is right there between 3 and 5. You can write it of interval notation. Like I just do the graphical notation, but interval notation, we can write it like this, interval notation. You can do is 3 parentheses and 5 bracket. If they were asked you to write set builder notation, they don't ask you here, but if they did ask you set builder notation, you could do x such that x is between 3 and 5. That's the set builder notation. Set x such that for all x, greater than 3 and less than or equal to 5. A great examples. If you want to do another examples, again, remember in this case, we are solving compound inequalities containing and. We have one more examples probably we can do in this case before we start with union of sets. Look at this one. We do exactly the same. First of all, we subtract 4 from everywhere to make sure that we isolate the x term. So we still have negative x in the middle. 2 minus 4 is negative 2. And then we have 3. As I said, the problem is the coefficient of x must be 1, positive one. So because we have negative, remember, if I see negative x is the same thing saying negative 1 times x. Okay, so negative x is negative 1 times x. So if I divide everywhere by negative 1, or if I multiply by negative 1, remember, answer would be the same. So what I do here, dividing, I have negative over negative give you positive, but that sign would change. Okay, so we're gonna change it into we switch the inequality symbols. So the first thing to do is always try to distribute properties if it's possible. Subtract from each part to isolate the x term. You simplify each part. All right, we divide. So remember that the sign direction changes when you divide by a number less than 0. That's why you see that inequality symbols change. So we do this, then we can rewrite it. It's either you leave it like this, that would be fine, but it's more appropriate to rewrite it because we will see x is, you see this part right there? You can read it, x is greater than negative 3, right? X greater than negative 3. And you see that part, x, that part right there, x is less than 2. We said less than 2. So it's either way, answer would be this same. All right. Now, look at the answer right there. We can graph it on a number line. Suppose those lines are straight, okay? 0, 1, 2, 3, -1, -2, and -3. We said that we have only less than, strictly less than, and strictly greater than, so we're gonna use parentheses. Here we go. All right. Now, this is the solutions. If you want an interval notation, interval notation for that, we're gonna have -3 and 2. Oh, that's 2. I need to fix that one. Oops. You know what? I'm gonna put it right there. I put it again so you can see where we are. Okay. Voila. So we do this one only. So between -3 and 2. Now, we use some examples to show how to solve compound inequalities containing and, but we also need to use compound inequalities containing or. But before we talk about or, let's talk about finding the unions of two sets. So when we have a union, remember at the beginning I said if you have two sets and take the common elements between the two sets, we call it intersection. But union set is when you combine them all. You take them all. So you take everything that you find in A, or everything you find in B or both sets. So we said the solution set of a compound inequality form with or is the union of the individual solution set. Okay, so union of two sets, the unions of two sets A and B is the set of all of elements that belong to either of the sets. A union B is another. So if I want, I can rewrite A union B, you see the symbols, is X such that X is an element of A, or remember, I don't say and. I don't say and. I say or X is an element of B. Or okay, so it's either one. For examples, let's suppose we have A equal A, B, C, D, E, F, and B is B, D, G, H, I, K. I just take it, you understand. So you see here, we can do both. We can either looking for A or B, which is the intersection. Remember intersection, but let's do that one first. The intersection of A and B, intersection elements you see in both. What are the intersections here? Yes, intersection is B, D, D. Those are the intersection. So it's only BD. Now, union A, union B, okay? A union B is all elements in A or all elements in B, except we don't repeat them. So like I say A, B, even though I see B in A and B, I'm not gonna take B twice. I'm taking only one time. C, A, B, C, D, I'm not taking it twice. E, F, G, H, I, K. See, I make a list of all those elements, and we use that symbol like a U shape to express unions of sets. All right. So I think this one will help you. Let's do an examples, a formal examples for this. The formal examples we can count on is to ask you find the union, right? If they were asking you for the intersection, that's you see, intersection. What are the intersection elements you see in both? Well, remember that's the previous example, 4 and 6. Those are the intersection. But they ask you to find the union and union A. If I call this one A and I call this one B, so I can say A union B is all the elements you see in A, 2, 3, 4, 5, 6, and 8. I don't repeat 4 twice. I don't repeat 6 twice. Even though they belong to both sets, I only repeat them once. So this is the unions of sets. Of course, in a different algebra course, you should be able to cover all the real numbers and union of sets of real numbers. All right. So the numbers that are in either set are 2, 3, 4, 5, 6, and 8. This set is the union. How about solving compound inequalities containing or? Or means unions, right? So look, in this case, anytime you see and, you see intersection. Anytime you see or, it means union. Okay. Now, if we look at the next examples where they ask you to solve 5 times x minus 1 greater than or equal to -5, or they put or. So what we need to do, as I said, is usually take the first one you solve, greater or equal to -5. First of all, you need to distribute. I believe by now everyone can distribute. If you add 5 to both sides to get rid of the 5 on the left, so you have 5x greater than or equal to what? Yeah, -5 plus 5 is 0. So if you divide by 5 from both sides, so you end up having x is greater or equal to 0. So this is our first answer. How to graph it? We know x is greater or equal to 0. If you graph it on a number line, we have 0 here, 1, 2, 3, -1, -2, -3. Now they said it is greater than 0, and we were greater or equal to 0. We're gonna use a bracket. Okay, then we know it's gonna go to the right because it's greater than 0. Okay, so if you want, you could even write the solutions as 0, infinity. That's interval notation. We can write it that way and it would be all fine. But remember, the other equations is or, where we have 5 minus x less than 11. So if we subtract 5 from both sides, we're going to have -x less than 6. Do you remember what happened when there is a negative in front of the x? You should remember that. You should remember that. I'll let you enjoy it. So you need to remember that the sign direction changes when you divide by a number less than 0. So at this point, the answer here would be x greater than -6. So how to graph it? We have x greater than -6. I'm gonna just graph like this again, and I put 0 in the middle, -1, -2, -3, -4, -5, -6. 1, 2, 3, 4, etc. Now, what we need to see in the second equation is like they said, x is greater than -6. I check where is -6 right there. So I'm going to put parentheses because it's strictly greater than, and we go to the right. Now, if we were doing intersection, we're going to take only 0 to infinity for the solutions. The problem, I mean, here, remember, we have -6, infinity. But now our goal is to graph x greater than or equal to 0 or x greater than -6. So when you graph it on this number line right there, having 0 here, -1, -2, -3, -4, -5, -6, 1, 2, 3, 4, etc. We take all the areas as long as there is a green part on them, we take them all. The first one start at 0, but the second one start at -6. So we have no choice. We must take it from -6. So how are we gonna do it? We take -6 to the infinity because it's belong to both of the previous ones. So that's all. Or we take the unions of the two sets. We find all the points that are in either set. So we take either, everything because it started with 0. So our solutions here is really -6 infinity. So that's the solution, the final solutions. When you do the unions, it all depends. I mean, when you do the intersection, it all depends. Sometimes you need to do three graphs. But if you have something between as a number on the left and on the right, you don't need to do three graphs, three number lines. But for unions, we're doing three of them to make sure that we get it correct. Maybe doing a last one, just to make sure you get it for the homework, because here looking at you have negative 2x minus 5 less than negative 3. If we add 5 to both sides, we're gonna have negative 2x less than 2. If we divide by negative 2, remember what happened when you divide by a negative, the inequality symbols switch. So this is the solutions. We have x greater than negative 1. And when you graph it on a number line, 0, negative 1, x should be greater. Okay, let's suppose I'm not gonna use that one because there is two ways to do it. I can do it like a big dot. Don't fill up the dot. So we go left, right. It still means answer is negative 1, 0. Okay. And the second one, look at the second one, or 6x less than 0 if we divide by 6 from both sides. Remember, a non-zero number divided by a 0 divided by a non-zero number is 0. So x would be less than 0. So even when I graph x less than 0, so I go like that. 0 is here, negative 1 is here, right? I can do 1 here, you know, 1 there. Now, how are we gonna do it? If I go less than 0, remember strictly less than, that means it's parentheses. Or I can use a dot. Don't fill it. Don't fill the dot. So leave it like this, and we're gonna go to the left because it's less than. Okay. What is the solution set? Because remember, we need to take the unions of both sets. What's gonna happen when you take the unions of both sets? So union of both sets, in this case, it's everything because we go both directions, you know? So answer for this one right there, when we have x greater than negative 1 or x less than 0, if we construct something like this, 0, oh, no, 1, 0, negative 1, we can say, look, we start from negative 1 and we go to the infinity. Okay, so that's the first thing we do. And then we start also from 0, then we go to the other side. So that means we take everything. We definitely take everything. So solution, set interval solution is negative infinity and infinity. All right. So hope this one really help you understand this first chapter. A section on compound inequalities. We'll come back with absolute value equations. In the meantime, if you have any questions, do not hesitate to let me know. Have a good day.